What about ye? Volvo XC90 2.4 D5 common rail diesel. And this one has 274,453 thousand miles on it. And no engine management light on. Everything's grand. Or so it might seem, because this car was in for some routine stuff a while ago, and we did a full system scan. It brought up a few wee codes, and guy wants it fixed. You know, passionate owner this car has, you know. So when we showed him that there, antenna light ring signal missing. Now that is the wee light on your where you put your ignition key in. So he wanted that fixed, no problem at all. Air quality sensor and the climate control, not really too bothered about that. But this one, these two were important. 6662 and 6663. So glow relay control faulty signal, and same again for 663. So just to let you know, as a wee bit of information, see that 6662, that 2 means cylinder 2. And the 3 means cylinder 3. So that's telling me that he's a couple of dodgy glow plugs in cylinder 2 and 3. And I told him that you want to address that, because a lot of modern cars use the glow plugs for DPF regeneration. And if you have faults like that in there, you won't get a regeneration. It won't regenerate the DPF. So you could end up with a block DPF. So in these D5 Volvo diesels, dead easy, absolute gift, and never usually have a problem with them seizing in or whatever. There's 280,000 miles in this car, so this one here would maybe be a good example. This video, I'm sort of going to focus more on testing glow plugs rather than removing these, because they're a gift, like. So anyway, in behind there we have cylinder number 1 glow plug, and you can just about see it in the wiring. There's number 2, there's number 3, it's behind that pipe there. Number 4 is in there, and that's 5 there behind that pipe. So we'll get them wires off, and we'll have a wee look-see, and we'll just unplug it. So I'm going to use these guys here to help us with that. So we'll put that on in behind there, just catch the body of it, and a good sharp tug towards you. Just like that. So I did a video before about testing glow plugs, and it was a wee bit more in depth than what we're going to do here. This is more sort of real world, but the point of that video, and I'll leave a link in the cards up here for that, it was on a Vauxhall. We used a scope, and the point of that video was to prove that even though the glow plugs might test okay with, you know, the rudimentary sort of real world methods that people use, you know, they're not all performing the same. And that was to sort of show why then that we change the glow plugs as a suite. In other words, all of them at the same time. I'll just recap that Vauxhall 4-cylinder video where we test the resistances of the glow plugs to 2 decimal places on the Vantage Pro there. So as accurate as we can get it. Now our Volvo here has 5 cylinders, and this one just has the 4. So we take the measurements of the resistances of all the 4 glow plugs, and then we scope the current draw on each of the 4 cylinders. So we can see in cylinder 1 there, 71 ohms. So it's basically open circuit and no current draw whatsoever. On cylinder 2, 0.59 off an ohm, and the current draw is about 15 amps or something like that. Cylinder 3, 0.69 of an ohm, a lot lower current draw, and cylinder 4 is also 0.69 of an ohm, but it has the highest current draw, which is probably the healthiest glow plug there of the lot of them. Even though the resistances on the three active glow plugs there are very similar, it doesn't tell us the performance of the glow plugs. So I'm not saying that the resistance check is no use, but it just doesn't tell us the full story. So we have fault codes here for 2 and 3. So a quick test, you know, if they're open circuit, you can just use a test light. So test light's on battery positive over there. So if we hit the anywhere metal, it lights up. I'll just turn this light off here so you can see a wee bit better. So the test light there lights up. Incidentally, that is an OTC 3633, good big long lead on, and that there's it's known as the scanner Danner test light. That's available on the Amazon store, Dave Stirl Amazon store. In the UK, shipped to the UK. It doesn't come from the United States, and it's about 20 odd quid. So sometimes out of stock, but you need to keep your eye on it. But it's there anyway, if you want one of them. So brilliant wee test light. Like, what we can do is we'll see if, I don't know where else will come up on camera. So there's number 1 lit up. So this is if the glow plug is making a circuit, you know, it's giving you a path to ground. We're on number 2, and it's lighting up, but it's like a dim light. There. Number 3, no light whatsoever. It's going to that 2 again. Number 4 then. Big bright light in that. And number 5, big bright light in that. So here's that number 2 again. Appreciate you couldn't really see it there very well. So bit of a dim light going on there. So if I tested the earth, the ground there, that's what we should be getting. Nice big bright light. Now, testing glow plugs, there's probably a plethora of videos on the YouTube. We're going to go a wee bit more in depth. Not going to use an oscilloscope this time, but when we get these glow plugs out, we're going to bench test them, and we're going to talk about various things like, you know, whatever you do, the majority of glow plugs nowadays don't run on 12 volts, so don't put 12 volts on them. Now, you could argue, well, there's 12 volts at the tip of that, as we can see here. But there's a resistance here. There's a resistance in this bulb, you know. So it's okay to use a 12 volt on a test light to test these glow plugs. Now, I wouldn't hold it on for any length of time, because these glow plugs actually run at 4.4 volts. So a quick way of determining that when they're in the car. So how do you know that when they're in the car? Well, you could test the wiring, like, you know, but see glow plugs. So the one on the left has a black ring on it. Then there's a red ring, and then those two there have like a white ring. Well, that one is a 12 volt plug. That one is a 4.4 or 5 volt plug. Now you can get glow plugs that are like 7 volts and all too. But generally speaking, these tops here tell you the voltage. And you see the white ring on these here. White ring means it's a ceramic plug. But these run at 5 volts as well, or 4.4. So if you can get a wee eyeball on the top, modern cars now, they're nearly all, they'll have that red ring on it. So before you want to take the glow plugs out, you want to give them a blow. You know, just get rid of the dust and the dirt around the tip, and or where the threads are, you know, where it's threaded in, and you can by all means give it a wee bit of a squirt on the threads, and let that soak in for a while. For what that does to be quite honest with you, very little, because it's not the threads that makes them stick. They don't stick in the threads, and we'll talk about that later on. You know, it's worthwhile having the engine maybe warm, you know, not like roasting hot, but, you know, on a warm engine. If your engine's warm, just be careful on pulling the plugs, because the plastic will be more supple and stuff like that. So a couple of wee caveats there to consider before you go to take them out. And of course, the other one that most people do, you know, the test light is probably good enough if you're going to change them all anyway. But as I say, the point of this is this is the reason why we change all of them, even though they might test all right or appear to be all right. But anyway, there's number one. So that test light lit up pretty bright. So you're looking for under known 0.6, 0.7, whatever. That's telling you you're making a circuit. So our number two, which was the dim light on our OTC tester, and we'll have 47.8 ohms. Number three then, which didn't light up at all. So we suspect that's completely open circuit. So that's kiloohms, 4.2 kilo ohms. And sure, we'll go on to another one here, just for a laugh. And that should be pretty good. So that should be in around the 0.8. So that's slightly different there. So, you know, still work, but it'll not function very well, that one, probably. So before we continue, I'm going to do a shout out for another YouTube channel. And here's it here, Kennedy's Garage. What's that, 496 subscribers. So for the output he has there, definitely, you know, the amount of subscribers he has doesn't reflect the content. It's completely real world. This is this guy's own business, his own garage, and he takes the time to film stuff and to stand in front of the camera and explain what he's doing and what he's found and stuff like that, you know. So this is true real world stuff. It's you know, there's no editing really, and you know, he doesn't put music over it and does all fancy jingles and all that nonsense. So Peter is in County Waterford, and I'm in the north of Ireland, so he's right way down in the south of Ireland, so he's a completely different accent than myself, but nevertheless, you know, he really does take his time and explain things there as well. Does a lot of scoping, uses a snap-on versus edge quite a bit in his videos. There's a wee bit of bench testing, a bit like what I do myself, you know, and definitely worth a subscription. And myself and Peter's accents are quite different, as a lot of people would say that the northern accent is harsher and maybe even possibly intimidating.
Call centres are from here, especially the ones that are looking money, like HMRC. They have a call centre here.
No way, do
and
they?
so they can ring people and go, you haven't paid your tax.
Our accent can sound quite threatening, but it works against you some of this. It's my fault. We didn't have a hole-in-the-wall game with a sitcom here. Never made it in the UK, and it's entirely my fault, because I sent a whole lot of DVDs to the BBC in London, and I rang them up a week later and said, this is a hole-in-the-wall gang in Belfast. We sent you a package.
Right, back to this engine here, this glow plug testing here. Right, so this is where we hang. Normally people don't see if you find the glow plugs to be open circuit over. That's usually about it. You know, you don't go any further than that. But if you want to do a wiring check, we did say these glow plugs have the red band on them, the red tip on them. So we'll see what voltage is going to come out of this here. You know, it mightn't be 12 volts. Is it going to be 5 volts? What's a crack? Well, again, in the previous video I did show this, but anyway. So we're connected into one of the glow plug wires. Now, another wee caveat here is sometimes your glow plugs may not come on if it's, you know, if ambient temperature is too warm and, you know, the engine's warm or whatever. So let me see. It's 22 degrees in here, according to that. It doesn't feel like it, I can tell you. And right, we're back on the volts again. So what we could do, to fool the engine is that's the coolant temperature sensor there. So we can disconnect that, and that'll go to -40 then, you know, on an open circuit. So if you're getting nothing, it's worthwhile keeping that in mind. And we'll just turn the key here and see what happens. Let me see. .3 when it jumped up and then down. So what's happening there? This voltmeter, I can't really see it because what's actually happening, it's happening too quickly. So there's actually a frequency here. So I took that on to hertz, and we'll do it again. On frequency, ignition on. So we're seeing, what are we seeing there? 32 hertz. So same test on a graph, and we can see what's going on better, I think. So ignition on. So it's gone off and on, but it is 12 volts there. So here we can see the scale, it is indeed gone up to 12 volts. So even though it's only a 5 volt plug, or 4.4, so we can see the 12 volt for a period of time, but it's pulsed. So it's on for a wee bit longer here, and then very, very short on the 12 volts. So the car doesn't give it 5 volts, you know, it pulses the 12 volts. And it stands to reason then, if you put straight 12 volts then onto a 5 volt plug for any period of time, well, you're going to blow it, clearly. Right, well, that might seem blatantly obvious, but anyway, you know, right, this might sound another blatantly obvious one. Yeah, I like to use quarter for removing glow plugs. Can have the engine warm. These D5s, never usually a problem. You know, you need to make sure that the socket's deep enough for it to accept it. It's 8mm. So I like to go on nice and straight as well. No wobbling about. I don't like to use wobble joints. This is a straight socket, and I don't like to use universal joints either, because you know you're going to move side to side then by doing that. So I like to go on as straight as possible, and sometimes I suppose you have to use wobble joints if you can't get at them. But you know, so the whole thing about this is, you know, you go by feel. You know, if you think you're going to snap them, or you're worried about snapping them, you know, so, and it just goes loose with what, 1/8 of a turn, you know, and spin her out the rest of the way. And I'll get all these out. They all should come the same, so nothing there's loose, nothing's ready to come out. Let me see, get on this one. So anything that's in your road, in your way, you need to get on nice and straight. Make sure you're on nice and straight and secure. Now, the wee quarter is just so that, you know, you're not putting excessive force on it. That's why I use quarter. Now, you see, it's probably to put it in, but so, and she goes loose. If it starts squeaking or scraping whenever you're turning it, you know, on the way out, well, that is a sign of the tip is carboned up. So where these things seize and how these things seize up is, there we go. This end bit, if it bulges out, if it gets wider, you know, if it sort of explodes and it's sort of blowing, and if this is, whenever you're turning it, is scracking, then that is actually this. Stay in focus. Now, this piece here, this bit here is the seat. So that's actually where it seals in the cylinder head. So see a lot of people, and this is now, I did a video before on spark plugs, anti-seize, link up here in the cards up there, you know. A lot of people put anti-seize around the threads and all that old jazz. And that's not where the seize, it doesn't seize in the threads, it's not the threads at all, you know. So in that video where I did on spark plugs, anti-seize, the main takeaway, the main thing that comes out of that is if you put anti-seize on the threads of spark plugs, anything at all, you will then over torque it, and then that is pressing this seat, we can stay in focus, this seat into the cylinder head. It's sort of digging into it, and it's going to cause you problems. And in that video as well, some of the commenters, quite rightly, and I totally agree, say that the heat on copper grease and anti-seize type stuff, you know, it sort of carbonizes it, it's going to cake it up. You know, I've seen copper grease on that's been on brakes and stuff, and it just cakes it up. It's like as if you imagine if you put it in the oven, you know what it's going to end up like. But anyway, so no anti-seize on threads because it doesn't seize on the threads. The mating surface to the head is that seat, and if that bulges out, it's that is the thing that causes the problems, not the threads. So people have asked me before about reaming. So with all 5 plugs out there, as you can see, they all come out like a lamb, no bar at all. So as I said, if that comes out and that slightly bulges or is carboned up and it squeaks in the way out, then yes, it is a good idea to ream it. So that's what a reamer looks like. And these are far too big for this application, but this one here would do that. Those ones are the very best. And you screw it on the end of this thing here, and in you go. But I don't do it as a general rule of thumb. You know, I don't do it if I don't have to. And this thing's not focusing today. But anyway, that's the crack with reaming. Only if you have to. That's my take on it anyway. So these are our replacements. These Bosch ones here with the red tip. So they're 4.4 volts. And clearly we'll want to just check the same length and thread as the ones that come out of it. So in dry, as a bone, no anti-seize, none of that old nonsense. And they just gently put it in and make a start by hand till it's snug. That's it. Your new glow plugs, or heater plugs as the manufacturers call them, you know, by all means you can do a resistance check on them, you know, before you put them in, make sure they're alright. But whatever you do, don't put a straight 12 volts onto a 5 volt plug. And you might think, well, that's crazy, who the hell would do that? Well, I'm not going to tell you who it is, but there's a video on YouTube, and there's a guy who does exactly that. So these are very skinny glow plugs, very small, you know, and the spec for that, for these ones, is 8 Newton meters. So if you put anti-seize, you will over torque them, even though your torque wrench says 8 Newton meters, but it will actually be, you know, torqued further than the actual 8. So it's very little. So we saw on our voltage capture, if you remember, you know, there was slightly wider pulses at the start at the 12 volts, and then it petered off with very, very narrow pulses. So we'll see that reflected in the current here, hopefully. So the resistance is going to change whenever the glow plug heats. So therefore the current is going to change, you know. But nevertheless, glow plugs are changed, not Volvo. So set a couple of wee things up on the bench here just for a bit of a laugh here. We're going to put 12 volts straight into these 5-volt plugs and see what happens. So I've marked them. So that was glow plug number 1 there. And we can see the resistance is 0.6 of an ohm. So that should be pretty good, that one. And we'll have a 12-volt car battery lurking in the background here. And amp clamp on there. So we're going to look at the current, just in numbers. And we'll see how long this lasts with a straight 12 volts. So this is why you don't do it. So you can see the current dropping off, and that's just the residual heat. So what did that last? A few seconds there. That's now going open circuit. So if we test that again, no matter what way it is. .75 ohms. So that's now a dud. So it took 20 amps and ruptured. We'll do all these, will we? A bit boring. Number 2, what was number 2? There was a bit of, it was sort of like a halfway house, wasn't it? So let's see. .47 ohms. Oh, I mightn't get anything out of that. We'll see. Deed. Note. Next one. Number 3. No point doing that. That was open circuit, wasn't it? Oh, kilo ohms. 4. We'll blow up number 4. Because that was pretty good, I think. Yeah, 0.6. Not a bad glow plug, that. So when the current went to 0, that's it blowing. So it's not even 5 seconds, it's a few seconds on full 12 volts. You'll blow them. And finally, we might as well, we'll do 5 here. What was that? That's about 0.6 as well. So you had 2 definite bad ones. The rest of them seem to be much the same. And bang. All right. Maybe get something out of that. All the best. And hold on. Just one last thing. Just Just noticed this. I thought I would show it here. Right. So I said earlier on that, you know, what actually seizes the glow plugs. So here's 2 that we've blown up. So that's 1 and 4. And that 3 is the one that was open circuit, so we didn't blow it up. And the end has, the tip there has bulged. It's swollen up. And there's a bit of a dingleberry on it. So that is what seizes your glow plugs. That's why you can't get your glow plugs out. Plus carbon and whatever else, you know. But if they have bulged at the end, that's the problem. That's why your glow plug seizes, and you know, it sticks. So there we go.